Hello, everyone. I hope you're doing well. My name is Sayam and welcome back to the channel, right? Today, we're gonna solve the second question of today's contest. Trust me, guys, this is very, very simple problem. Like, it is very simple. Actually, it is very simple. I don't know why they make this five pointer, and we'll see. If you're not able to solve this problem, no worry. We'll understand the detailed intuition, and this is a problem which will solve you can using this problem you can solve multiple problems, right? Let's try to deep dive the intuition in this. Minimum operation to make binary palindromes. अरे भाई palindrome से तो प्यार है लीट कोड को. You're given an integer array nums. बेहतरीन num से भी प्यार है. For each element of num I, you perform the following operation any number of times including zero. Okay. Increase num I by one. अच्छा. You can increase with one or decrease by one. Okay. A number is called binary palindrome if it's binary represented without leading zeros. Very, very, very important keyword, without leading zeros. Okay, cool. Without leading zeros, it should not be, it should be a palindrome. Your task, that means what? 101 is a binary palindrome. 01 is not a binary palindrome. That means you cannot put a leading zero. Let's say it's like 10, or you can say you cannot put it's a binary representation. You cannot put a zero to make it a binary palindrome. That is the idea of the problem. Okay, cool. And then the finally saying it that your task is to return an integer array answer. Where answer I represent the minimum number of operation required to convert nums of I into a binary palindrome. Okay, okay. See, जब भी तुमको इस तरह के क्वेश्चंस मिलते हैं, obviously the first task is to see the constraints. What are the constraints saying? Constraints की क्या कहानी है? अब कंस्ट्रेंट से जाके देखा तो खुश हो गए होगे तुम काफी लोग. 5000, वाओ 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 वाओ. 5000, that makes sense, that makes sense. Can we do something better? Yes, yes. Maybe some people have got TLE after that also. I will tell you how you can get good and intuitive solution from here. Fine, we got 5000. Fine, so we can do n square solution. Cool. Bits also है तो कुछ तो 31 का भी फील आ रहा है. We can do that also. Cool, let's try to see. Okay. Hmm. Binary palindrome banana है. And interesting idea is you can increase the number or you can decrease the number. Means let's say you have a 5. You have to find the closest binary palindromic number. Okay. That is our idea. It could be here also. It could be here also. It could be on the right side. Or either it could be on the left side. Right. Absolutely. Hmm. 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 And interestingly, number भी है ना यार till 5000. N is also till 5000 and the number is also till 5000. Acha, right. Absolutely, you are right. Now, can we think about something here that, okay, I need to think about something that a number is called binary palindromic and it should be, we have to find this closest number. So, when we are iterating into our nums array, let's say we are iterating in our nums array and we have to find this closest. How can we get this closest? We can actually iterate also, interestingly. Again, because n is still 5000, we have n square approach. Somehow, if we can pre-compute all these binary palindromes, will it help us? Will it help us? Oh, हाँ Sayam, it will definitely help us. What we can do for the current number, we can just iterate in this binary palindrome wala array, and then we can find the minimum distance among all the pairs. I know that you will say you can optimize this further, but in a brute force way, if you think about, yes, we can absolutely do this. That let's try to find out all the binary palindromic number, not very all, only in the range 5000 because our number is still 5000 only. So in the 5000 range, we can find these numbers, right? And how can we check whether a number is binary palindromic or not? How much time complexity do you think it will require? अरे यार, it is very simple. What you can do, you just need to take a n and you have to convert into this binary string, and just check this is a palindrome or not. Check. So this conversion, how much time it takes? It take log n time. Check how much time it will take. Log n time only. Why? Because the length is log n. So it will take actually the length amount of time, but actually the length is log n itself. That's why it will take log n amount of time. And that is the crucial part. So you can build this array, pre-compute this array, all the binary palindromes into a separate array. And then what you can do, you can for each element in I in nums, for each element in nums, for each element, you can find you can find the closest difference. The closest difference. That is the beautiful idea about this problem. Right? Let us try to see this with the help of an example. This is 6, 7, and 12. So what we can do, let's try to think what are the binary palindromes. Is 1 a binary palindrome? Yes. We'll put into a array. Is 2 is there? No. Is 3 is there? 3 is there. Yes. 3 is also there because 1, 1. 1 1 is there. 4 is there? No. 5 is there? Yes. 1 0 1. It's a binary palindrome. 5 is also there. 6 is there? No. 7 is there? Yes. It's 1 1 1. So we can put 7 also. It's 8 is there? No. Is 9 is there? Yes. 9 is also there. 1 0 0 1. So we'll put 9 also. And for simplicity, I'm going the closest till 12 itself, so no need to go further beyond that. So and we can go 10. 10 is also no, 10 is not there. 11, 11 I have to think about. 11 is like what, this 0 1 1 no. 12, 12 is also not there. 13, 13 is also not there, I guess, because this is 13. No. 14, 14 is also not there. 15, 15 is there. Right, 50. This is the closest up till 12. We can go beyond that also, but no need. Now, from this pre-computed array, we can finally what we can do, iterate in this array and finally compute our answer. We'll go to 6, we'll compute the difference with all the elements. Because I already told you the answer will come from the closest of left and closest of right. But the problem is we can get the right wala part, but can we get the left wala part also in optimized way? This is difficult to get. This is difficult to get. You can get it. The next smaller elements, next larger element, that is the idea you have to implement. But in the contest, what I did, I just calculated brute force from all the elements, the difference, and try to minimize that. So what you can do, what is the closest left is that. So closest left is 5 or 7. Either you can do. The answer would be 1. Right? The difference is the distance, and that is the number of operations required, right? For 7, it is 0. Obviously, it itself is the answer. And the 12, it could be 15 or it could be 9. 3 would be the answer. And that is the beautiful idea of this problem. Right? That's all about this problem. It's not very difficult, right? Let me just quickly show you the implementation. What we did, it's very simple. What we just calculated, the check of I, and then if it is true, if it is a binary palindrome, we just push back into our I. Actually, you should run around 6,000 because it could happen that the for 5,000 element, what could be the closest? The next also we have to figure out, right? But luckily that worked. That means the closest part is lies on the left side also. So you can put actually this limit to be 6,000 because in the worst case scenario, if LeetCode is nasty, it could go beyond that also, right? Because the last element, let's say the number is 5,000. It might be that I have not explored the right part of this 5,000, right? I have to just search in the left part. But surprisingly, the left part is the optimal part. Right part is maybe not optimal. That's why this is working. But actually, you should write 6,000 here, right? And that won't change much the time complexity. So firstly, we computed it. How we can check that? Firstly, we converted into a binary palindrome. Since see, this is the invert inverted part of the uh, binary thing of the number. But since it is a palindrome, it should be ideally same from both the sides. So it does not matter. You don't need to reverse it. That is also very, very interesting idea, right? And then just finally we need to what? Just check the palindrome part. This code will run for log n time only because the length is log n itself. Absolutely right. And then we just checked this overall the time complexity is of n log n, or you can say 5,000 log n, or n log n also you can say that. And then finally what we can do that we can iterate on nums, and I just iterated on our this array also, binary palindromic array. Since there are not very much elements in the PL, Not all numbers are palindromes. It will be very small, not very small, but still a considerably small. But in the worst case scenario, let us consider n. So what we can do, just we maintain a mini, just calculate the difference from all the numbers. Ideally, we can optimize this part also, but still, this will also work. And then do let me know if you can optimize this part. By the way, I can find the next part, but can we find the previous part also in the optimal way? Just find the minimum difference between all the numbers and the final return the answer, because these all in the PL are all satisfy the binary palindromes. We can convert every number to this PL, but we want the minimum. We just find the minimum difference and finally return the answer. So I hope you understood the entire intuition, the thought process. And if you love the video, make sure you to subscribe to the channel and like the video. We'll see you in the next video then. Till then, keep learning. Good luck.